In this video, I'm going to walk through several voting methods. So what we're going to work through is understanding different voting methods, including majority rule, plurality, single runoff, sequential runoff, Borda count, which is also the point system, and the Condorcet method, which is also called pairwise comparison method. As I go through these, I'm going to give you a little bit of context for how they're used, where they might be used, and just some of the politics behind these different systems. So we're going to start off with the simplest of the systems, simplest in some ways, a majority system. A majority is simply the winner must get 50% plus 1. And there are a lot of systems that kind of require this by the end, getting to a majority. Now, that can obviously be difficult, and we're going to see some examples of how it can be difficult, and so it might take a lead up to this majority, but majority simply means 50% plus 1 vote. If you simply split 50-50, meaning if I get 5 votes, you get 5 votes, nobody wins because it's a split, so you do need to get 50% plus 1. There are some variations on this called supermajorities, which require a percentage higher than that of just a majority. These can include things like the filibuster. So for those of you that don't know what a filibuster is, in the Senate, politicians have the chance to kind of delay the votes if they are opposed to something that's going to be coming to the floor. If they just want to slow things down, there's processes they can use to delay that vote. And so there's a vote of cloture, which requires a supermajority of 60% to break that filibuster. Appointments and treaties a lot of times will take 60% of the senators to approve as well. Constitutional amendments require a supermajority of 2/3 of Congress individuals and 3/4 of states. So again, these supermajorities just being even higher than just that 50% plus 1 threshold. Let's see how a majority works. So let's determine who wins under this majority rule system. So we have Anton and we have Sally running an election. Anton wins 112 votes. Sally wins 122. So what I need to determine first is, what is that 50% plus 1? So I'm going to first calculate a total. And so very obviously this will just be 112 plus 122. And so when we add those two numbers together, we get 234. So if we think about half of that, or 50% same as half, that would be 117. So to win majority, these candidates need 117 plus 1, or 118. That's the magic number they have to get to. And so, obviously, if we look at these votes, Sally wins the election because she is over that majority. So Sally would be the winner of this election. Let's look at example 2. Let's determine the winner under majority rules. So Anton gets 104 votes, Sally wins 106, and Luna wins 24 votes. So this time we have a third candidate. I'm going to do exactly the same process. So to get a total, we're going to add up 104, 106, and 24. And so if we add these numbers together, we get the same 234 total votes. And so half of that is still 234 divided by 2, 117, which means to win a majority, the magic number is still 118. Nothing has changed from before except the fact that we have this third candidate. Now that we have this third candidate, Luna, what we see is Luna took some votes from both Anton and Sally. Neither of them have that 118 needed anymore. And so under this system, there is no winner. And this is one of the challenges of the majority rule, is that we can have a whole election and nobody reaches that majority. If we have more than two candidates, in fact, there's a good chance that we won't. And so then the question becomes, okay, well, what do we do from here? We have to have some way to narrow down to a winner. And so this is where we get into those other methods. The easiest of the other methods is a simple plurality. And under plurality, the winner is just the person with most votes. That's all there is to it. And so if we look back at those two earlier examples, right, the two ones we just did, in the first case, we said Sally wins because she cleared that 118 vote threshold she needed to win a majority. She still wins. She still has the most votes. Still a guarantee. But in that second example where we did not reach a majority, 106 was 12 votes shy of that majority needed. Well, Sally still wins this election because even though she doesn't have a majority, she does win a plurality. And so pluralities are a little bit easier because we don't have to get to that half plus one. That makes it a lot easier for systems where we have more than just 3 candidates running. We use this system a lot in the United States as well. A lot of elections are simply who gets the most votes. Now, there's some challenges to this. I think that if we think about 3 candidates, it's potentially possible that candidates have 33%, 33%, and 34%. Well, it doesn't seem like if you get 1% more than 2 other people, that necessarily means that you're the best candidate. Maybe those 2 other people were much more in agreement. Maybe if you kind of combine their 2 thoughts and their 2 amounts of votes, that person would have won. So the plurality, even though it's easy and convenient, it's not necessarily the best. And so that's what we're going to move into. What other systems do we have? And so we're going to look at first what's called a preference schedule. A preference schedule is simply a table that shows how voters rank candidates. And so kind of walk through this for a couple minutes. We can see that we've got some votes that have been cast. And so the way this would work is you'd have candidate A, B, C, and D on your ballot. So this is your ballot. And you would just walk into the ballot box. And rather than just, as we do now, selecting the candidate, putting your little, bubbling in the little bubble choices, that's how we do most of our elections in the United States. You just go in there and you bubble whoever you want. Under a preference schedule system, preference ballot, you would actually go in there and you'd rank the candidates. So, C is my favorite candidate, but if C doesn't win, I like A as well. B is all right, and D is really not my favorite. D I don't care for. So the nice thing about having a ballot like this is that what happens if A really just wasn't popular, C, my first choice, wasn't very popular. Most people didn't like C. Well, my vote would kind of have been wasted, right? Even though they're my favorite candidate. Under, just choosing one candidate. But under a preference schedule, now, because I've ranked these candidates, there's a way for the election officials to kind of weigh, okay, well, yeah, C wasn't very popular, but maybe A, my vote still counts for A. So that's what we're going to see in the next few voting systems. Even though your candidate might be eliminated right from the start, your vote still matters. It can still get weighed into the system. So if we look at this preference schedule in front of you here, we've received 4 different lists, and these would be 4 different possibilities. So one individual went in, selected, said, hey, B is my favorite candidate, A is my second favorite, C, and then D is my least favorite candidate. In fact, there are 10 individuals that selected that same way. So these were really 10 different ballots that we counted up, and we said, okay, 10 people agree this is exactly the order of the candidates. 9 other individuals said C is their favorite, A is their second favorite, D, and then B is their least favorite. 8 individuals said D is their favorite, C is their second favorite, A, and then B. Then only 3 individuals said B is their favorite, D is their favorite, A, and then C. Now notice there's actually 2 lists that start with B, so why didn't I join these? Well, the 2 different ballots that were turned in, they had different options on the second choice. Both these 10 people and these 3 people here, they all said candidate B is our favorite. But if we don't get candidate B, these people said, oh, I prefer A, and these people said, oh, I prefer D. So in both these 2 columns, B won, they had the most votes, or they came in first, but their second choice candidate was a little different. Notice in all cases, A never actually won. A was never anybody's first choice. And so we'll see how this plays into the voting. First type of system we're going to look at is what's called a single runoff. And this is one of the most common in the United States. If you don't hit the majority, or breaking elections down to multiple stages, as we do with primary election, you go and you select one candidate, and the top vote getters kind of continue on to the general election. So this is very common within the United States. Single runoff, the top 2 vote getters get to move on to the final election. So we want to determine who wins in this system. So top 2 vote getters right now, we have to count up. So let's think about how many votes each of A, B, C, and D got. Well, A is easy. A got no first place votes, so they're definitely out. A is not going to be in consideration here. B, well, B was these 10 individuals' first choice. Also, these 3 individuals' first choice. So B's got 13 votes right now. C wins out with this group of people. These 9 votes, they all said C was their favorite candidate. And then D, these 8 individuals here said that D was their favorite candidate. And so that's how these would break down. If it helps, you can think of these as that many different ballots. If we think about all the different ballots that were submitted, there's 10 here, there's 9 here, there's 8 here, and there's 3 here. That's a total of 30 ballots cast. Total of 30 votes. We can see those again here. That's the actual number of ballots. So there's one person that said B, A, C, D. Then there's another person that said B, A, C, D. There's 10 of them, in fact, and then 9 people, 8 people, so forth. So it's a total of 30 votes. That means to get to a majority, well, half would be equal to 15. So needed for a majority would be 15 plus 1 or 16 votes. We need 16 people to agree. Didn't happen. Under a majority, nobody would win. So then we go into our other methods and we could say, okay, yeah, B wins under the plurality, but what if B was really very unpopular with all those other folks? And it does seem like actually very unpopular with that other group. So maybe those other groups will come together and say, you know what, if we can't have B, or rather, if we can't have our top candidate or C or D, we don't want B to win. So even though B is seeming like the leader, very unpopular with the other groups of people, so maybe she is not actually the best leader. Maybe it's C or D. So what we're going to do is we're going to say, okay, whoever had the lowest votes gets eliminated. A is eliminated. Also D is eliminated from this election. B and C had the highest number of votes. Well, D, these 8 votes, we're not just going to ignore those 8 individuals. What we're going to do is we're going to give them to the candidate with the next highest choice. So after D, these 8 individuals would really like to see C win the election. So these 8 votes right here are going to go to C. And so now we have a total of 17 votes for C versus B is still at 13. And so obviously, which number is higher? The 17 is. So C would win under this election. Even though initially they didn't have the highest number of votes, once we eliminated those bottom candidates, A and D, C picked up those 8 votes from D. And so C would be the winner under this system of election. Next, we're going to look at a sequential runoff. In a sequential runoff, the bottom vote getter is eliminated and the votes go to the next top candidates. This process will continue until only one candidate is left. Now, for this example, it's going to feel very similar to the last because A never had a winning column. Let me write out what we have. So A, just like before, we said had 0, 13 for D, 9 for C, and 8 for D. So under this system, we take in multiple steps. So we say, okay, A is out. Their votes go to the next highest candidate. In this case, A didn't get any votes. And so we'd go to a second round. And in the second round, the only people left are B, C, D. So B still has 13, C has 9, and D has 8. So we're going to eliminate the next candidate. Next lowest candidate, try that C again, that's messy, 9. Next lowest candidate would be candidate D, so their votes get added on to C. And so we have 13 and 8. So if I can do basic math, 9 plus 8 is 13 and 17. Candidate C wins once again with the 17 votes. So because of the way that this table was set up, because A didn't have any votes, their votes never got redistributed. They didn't have any. But under a sequential runoff, because you're taking one at a time, that can affect the election if there are other candidates' votes going other places. So it's not just kind of looking at the top 2, it's eliminating the bottom one and working your way up. The next type of election system we have is what's called the Borda Count or the points system. This is going to be definitely the most involved, the most mathy, I'll say, because it requires us to do a lot of calculations. Under the previous two, we just kind of eliminate people, we add their votes to other people. Under this system, we're actually going to give people credit for every single position they finished in. So if you come in first, you get points. If you come in second, you get points. Third, you get points. Fourth choice, you still get points. But those points are going to be weighted according to your place of finish. So a last place finish only awards you a single point. I'm going to change that language right there. I'm going to change it to a point, not a vote. Whatever the total number of candidates is, that is the most votes you can receive, the most points you can receive. You get all of that for a first place finish. So if we look at this case, first place finish, because there's 4 candidates, you would get 4 points. Second, you would get 3 points. Third, you get 2 points. And then for a last place finish, or in this case fourth, you only get 1 point. So you get points for every single ballot, regardless of if you're first or fourth. So let's start doing the math. Candidate A. Well, in the first ballot, candidate A finished second. That means they get 3 points. There were 10 ballots that said the same thing. They all said candidate A in second. So A gets those 3 points 10 times over for those first 10 sets of ballots. In the next set of ballots, well, even though the top candidate was different, A is still finishing second, so it's still getting 3 points for those 9 ballots. In the third list, candidate A finished in third place, so it only gets 2 points for those 8 ballots. And then was again the third place finisher in the last count group of 3. So now I'm going to use my calculator to help me out here, make sure I get the right number. Add all these points together, we get a total of 79 points. Candidate A finishes with a total of 79 points. I'm going to do the same thing for B. Well, in the first column, B actually won, so they get all 4 points for those 10 votes. In the second column, a last place finish only gives you 1 point for those 9 votes. Only 1 point for those 8 votes. And then again, finishing in first gives all 4 points for those last 3 votes. So if I add these together, candidate B gets 69 points. So even though A never won, they are leading in this system so far. We don't know that they've won. We have to do C and D. But they've beaten B. Even though A never was selected first, they also were never selected last. And so what the Borda Count System is giving us the ability to do is kind of weigh that and say, okay, even though not people's favorite candidate, not the least favorite either. If we look at C, in the first column, they finished third, so they get 2 points for that. In the second column, they finished first, so all 4 points for those 9 voters. And then they finish in second place for that third column. And then the last column, they finish in last, so they get, should not be a 4, that should be a 1 for last place for those 3 ballots. So if we add these together, total of 83 points. And so candidate C would be in the lead so far. Let's look at candidate D. Candidate D was the 4th place choice in the first column, so they only get a single point. They were the 3rd place, so they get 2 points for that in the second column. Then they won the 3rd column, and then in the last they came in second again, so they get 3 points for that. And I'm going to add these together. And so candidate D gets 69 points as well. Like with B, they are also at the bottom. And so under this system, once again, C has won. But what we see is a lot closer. A was eliminated in the first round, both of the previous 2 systems, under the single runoff and sequential runoff. But even though they were never in first, they were always fairly popular too. So this system has taken that into consideration. I didn't mention the sequential runoff. The sequential runoff is used in certain places. It does take a little bit more work though, because it is that process of eliminating candidates from the bottom up. So it takes a little bit more time and a little bit more work. Don't see it as much. Tend to see that there are some places. Australia uses it, India, Iceland, Papua New Guinea, London uses it for their mayor, San Francisco uses it for their mayor. So a few places use it. The Borda Count, as we just saw, is even more involved than a sequential runoff, so it's used in several places. I had to do my homework for this one. So the Parliament of Nauru, that is an island nation of 10,000 people. There are 2 members of the Slovenian Assembly that are elected under this method, and there's a modified version of this in Iceland. It's not the pure Borda Count point system, but it's close to. So there's a few places that use it. You see it a lot more in smaller groups where you can calculate these things a little bit easier. So a lot of times committees or selection of people within companies, let's say, will use this system. Condorcet method, also called the pairwise comparison method. This is also used in some smaller organizations. I could not find any countries or any larger cities that use it, but some towns, organizations use it, and then also when trying to decide maybe a best course of action, so policy decisions, this can be used. But under this Condorcet method, each candidate is compared to every other candidate, and a candidate must win each of those comparisons to win. So we're just going to jump right into it to see how it works. I'm going to start with a comparison between A and B. So I'm going to put A and B side by side, and what I want to see is who ranks higher in each list. So in this first list, B is the higher candidate, so they win those 10 votes. I'm going to keep some notes down here. So B wins those 10. Next list, A is ahead of B, so A wins those 9 votes. Third list, A wins those 8 votes. And then in the last, B wins again, wins those 3 votes. And again, where am I getting these 10s, 8s, and 3s? That is the totals. Those are the total numbers of votes. So a 9 is 17, 10 and 3 is 13, and so candidate A wins between A and B in this comparison. Next, I'm going to compare A and C. A is ahead of C in the first grouping, so that's 10 votes for A. C is ahead of A in the second grouping, so C wins those 9 votes. In the third grouping, C is ahead of A, so C wins those 8 votes. And then the last grouping, A is ahead, so it wins those 13 votes. So we had 13 votes here, we had 17 votes for C, so C wins in the second head-to-head. Already I know that A cannot win this election. A has just fallen to C, so A is guaranteed not to be able to win under this system. But I do want to compare A and D. I need to know how all the different matchups look. So I'm going to go ahead and compare A and D as well. A is higher in the first list. A is higher in the second list, so A is already at 19 votes. They already have it wrapped up. D is higher than A in the last 2 columns, so it's 19 to 11. And 11 at A wins. What I'm already guaranteeing is that B cannot win this election. B is lost to A. I also guarantee that that D cannot win this election. D is lost to A. So what I'm really curious to see is, can C beat B and can C beat D? So we'll look in the first column. C is higher than D. 10 votes go to C. The next column, C wins those 9 votes. That's a total of 19. C already has it wrapped up. Excuse me, I was doing that wrong. I was looking at C and D. I was doing the next one. Let me talk about C and B first. C and B. B is ahead, so B wins those 10 votes. Then C wins the next 9. C wins the next 8. So C is going to take 17 compared to B's 13, so C wins that. C has to beat D if they want to be the winner for this election. And so C wins those 3 votes there. They've beaten D. C wins those 10 votes there. C is higher than D there, so 10 votes for C. 9 more votes for C, so that's 19 for C already. D wins the last 2, so that'd be 19 and 11. And so C wins yet again. So C will be our winner. Now, if you're looking at this saying, well, wait a minute, what if we had not had C win one of these? What if C had won 2 of 3? Is that good enough? No. To win under the preference table, the candidate must win every single matchup. So with pairwise comparison, it gives rise to a lot of undecided winners, or a lot of times where you just won't have a single winner. And so that is one of the challenges to it. I think that's why a lot of countries don't use it. It's nice for, like I said, policy decisions to really see, do we have an absolute favorite, one thing that always wins out? But it's a little bit harder because rarely is there going to be a clear, decisive winner in all cases. So in this case, there was. And so in this election, C was pretty well the universal winner, with the one exception of C would not have won a plurality. C didn't win a majority. C wouldn't have won the plurality. B had more at the very start. But once we ran a runoff, didn't matter the type of runoff, we saw that C was a winner. C won the Borda count, and C won the pairwise comparison as well. And so C won a lot of the election styles, not every single one.